Very good morning, dear students, and welcome to the class of mathematics. Today, I am going to teach you the chapter number 3, squares and square roots. Let us start the topic squares and square roots. Question number 1 is which of the following natural numbers are perfect squares, and give reason in support of answer. That means if it is a perfect square, then how can you say that it is a perfect square? And if not, then give reason. 7 to 9. First, I have done the prime factorization. You know that 729, the last digit is 9, therefore it is not divisible by 2. For 3, we just add up the sum of all the digits, and if the answer is divisible by 3, then the whole number is divisible by 3. That means it is the divisibility test of 3. So by doing the prime factorization, I got 3 pairs of 3. Now 729 has 3 perfect pairs of prime factors 3, and after the multiplication by applying a square I get 27. So it is a perfect square because it contains perfect pairs of prime factors 3, and yes, I can easily see that it is a square of 27. The next one question is the same 1024. I have done the prime factorization and I got 1, 2, 3, 4, 5 pairs of prime factors 2. Therefore, it is also a perfect square if in case only one prime factors remains and it is not paired up. So it is not a perfect square. The next question is find the smallest number which is a perfect. Find the smallest number by which 1008 should be multiplied to make it a perfect square. Always keep remember that if it is written that by what number it is to be multiplied or by what number it is to be divided, that means it is clearly written to you that it is not a perfect square. That means you have to multiply by a number or you have to divide by a number. So for checking that it's not a perfect square, I have to prime factorize. So the same I have to prime factorize here also. By doing the prime factorization, I got a pair of 2, again a pair of 2, a pair of 3, and a number 7 remains alone. So I have paired up all, but the 7 is still alone. So 1008 should be multiplied by 7 to make it a perfect square. I have written the statement, the whole statement, with the help of the question. The next question is show that each of the following is a perfect square. Also find the square number whose square is the given number. Same as question number 1 I have discussed with you. We will do the prime factorization here, and after doing the prime factorization we know that we got perfect pair of prime factors 2 and 3. So it is a perfect square. And whose square is this? To know this, just write. Just reduce a pair into 1 by applying a square on the whole bracket. So the number I got after reducing a pair into a number into 2 is 48. That means 2304 is square of 48. The next question is find the smallest number by which 5808 must be divided to make it a perfect square. Also find the number whose square is the resulting number. It is the same question I have discussed with you in case of multiplication and division. We always do prime factorization, and it's the same I have done here as prime factorization. From the statement it is very clear that it is not a perfect square. So I do the prime factorization first. Now in case 2 has a perfect pair, 2 has a perfect pair, 11 has a perfect pair, but the 3 remains alone. So in case of division I have to remove that factor, and to make, so I have written 5808 should be divided by 3 to make it a perfect square. And the resulting number, how I will find the resulting number of which it is a square? The resulting number has to be divided by 3. I have not written over here, but you will write in your notes, students. So because it is not asked in the question, but you should write this. So at last it is the square of by It is the square of which number? So I have reduced the factor of the pair of 2 into 2, 2 into 11 into 1. Then we will remove 3 from here because we have to divide by 3. So remove the factor 3. So the answer is 44. That's it, student, from my side. Hope you like the video.